Welcome to GrayYeon Math. For today's video, we are going to solve the area of this blue circle inscribed in a semicircle. And this small blue circle is actually defined by the points of this, uh, a leg of this yellow triangle, aside of this, on a point on this green semicircle, and this vertical line from the center of the semicircle. Three of these, these 3 points are the points of tangency of this blue circle with respect to the other figures. So, in the yellow right triangle, so this is a yellow right triangle because it is a triangle whose hypotenuse is also the diameter of the semicircle, and its dimensions are 8 for the shorter leg and 24 units for the hypotenuse. And we are required to find the area of the blue circle. Okay, so using the given, we can actually uh, take the cosine of theta. So, because as you can see, this is a right triangle, so we can make an equation using this given. So cosine of an angle. So let's say the angle is A. So is equal to the this is the angle A. So adjacent side over the hypotenuse, so 8 over 24. Okay, so as you can see, this larger uh, triangle, this is actually a right triangle, and this is actually similar to this smaller right triangle. Okay. So since this 8 is opposite the smaller angle, this angle, so it is opposite this angle. So this angle, and this is the larger angle of this smaller right triangle, similar to the previous largest one. So this is should be also A because it is opposite the longer leg for this smaller triangle. Okay, so next is I want you to notice these two tangent points of this point of tangency of this blue circle, and the line, the vertical line, and the leg of this largest right triangle. And this is actually, you can draw a line from that 2 points of tangency to the center, and these 2 points of tangency to the center, and this will be a right angle, and this will be a right angle. And if you draw a line from the center of the blue circle to this point of intersection of the vertical line and the leg of this largest right triangle, we can actually put two angles here. So let's say that this is theta, and these two angles are equal because of for tangents of the circle. So because these two triangles are actually congruent, so these two angles are theta. Okay, so you may ask why I use this, uh, why I used cosine of this angle earlier. So because later I will get this length, which is also a cosine of this uh, right triangle, the cosine. I need to get this length in relation to the radius that we are looking for to get the area of the circle. So this is also the radius. So I need to get this length later. So, but now you can actually notice that this uh, twice of theta is actually a vertical angle with A. So, as we all know, vertical angles are equal. So, we can replace this A with 2 theta. So, since they are vertical angles, so this becomes, we can actually make this cosine of 2 theta. Okay, so we can actually replace A with 2 theta. Okay, so this becomes 2 theta, 2 theta. And we forgot to simplify this. This becomes cosine 2 theta is actually, this is divisible by 8. So this becomes 1/3. Okay, so next is since we are after this distance, as I have mentioned earlier, this distance. So we can actually make a relationship between 2 theta and this theta inside this, I mean near this blue circle. So if we have cosine of theta as 1/3, cosine 2 theta, I mean cosine 2 theta as 1/3, and but cosine 2 theta is actually uh, cosine 2 theta is equal to 2 cosine squared theta minus 1. So we can actually get the value of cosine theta later in this formula. So cosine 2 theta is 1/3 is equal to 2 times cosine squared theta minus 1. So 1/3 plus 1 is equal to 2 cosine squared theta. So this becomes 3, 1. So 3 divided by 1 is 3 plus 3. So 2 cosine squared theta. So equal to 4/3. Okay. So is equal to 2 cosine squared of theta. So we can actually cancel this. This becomes 2 and this cancels out. So cosine squared theta is 2/3. And next is to simplify this by taking the square root of both sides. So this becomes cosine of theta equal to square root of 2 over the square root of 3. We just need rationalize later, not now, not for now. Okay, so next is we continue with what we got. We got cosine theta is equal to square root of 2 over square root of 3. So this implies that if we draw a right triangle, okay, uh, the hypotenuse is actually square root of 3 and the adjacent side is actually, since this is cosine, so this will be square root of 2. So if we try to get this side, then we just need to use Pythagorean theorem. So the hypotenuse is square root of 3 square. If we use Pythagorean theorem, we have c square is equal to a square plus b square. So c is equal to square root of 3 square is equal to the side a could be 2 square root of 2 squared plus b square. So this becomes 3 is equal to 2 plus b square. So b square is equal to 3 minus 2. So b square is equal to 1 and b is equal to 1. So this means that this right triangle has the opposite side to angle theta actually equal to 1. So we now completed the sides of this uh, reference right triangle. Okay, so next is we focus on these two right triangles that I have drawn. So earlier we got this right triangle with the hypotenuse of square root of 3, adjacent side to theta, square root of 2, and opposite side is 1. So if we compare it to the right triangle that we have here on the figure, okay, and I have extracted that triangle to be this triangle. So since we have this opposite to theta as R, then this corresponds to this one unit, which is opposite also the side of, I mean opposite the angle theta. So if that is 1, so in our case, we just need, if we have here 1, then to get the adjacent side, we just need to multiply this by square root of 2. So this means that 1 times square root of 2 will get the adjacent side. And for the figure, for the triangle on the figure, we have the r to be the opposite of theta. So this implies that we just need to multiply this r to square root of 2 to get this side. Okay, so to get this side. So on the figure, this becomes r square root of 2. Okay, so to put it in another way, so since let's say that tangent theta or opposite over adjacent, so we have 1 over square root of 2 is equal to r over, let's say this is x, so r over x, so x, if we cross multiply, we have r square root of 2 over 1. So this length is actually really equal to r square root of 2. So this is really r square root of 2. Okay, so next is I want you to notice that this, from the center of this I mean the center of the blue circle, is we can actually draw a line to this center of the semicircle. And we actually form a right triangle. Okay, so right triangle with the radius of this blue circle and this r square root of 2 and this length. So this r square root of 2 plus this length is one leg and the radius and this distance, the broken line distance. And this broken line distance is actually uh, a part of the radius because it can continue up to this point of tangency of this blue circle and the green semicircle. So this is also R. So since the radius is 12 because the diameter is 24, the diameter, so this is the also a radius. So the radius is 12, so this becomes the part of this broken distance is actually 12 minus r. So we actually form a right triangle. So with one leg as r and this other leg as a part, we got r square root of 2 in this part. So we are actually we are next to be after this leg, this distance below this intersection of the uh, blue line and the leg of this yellow circle. So this distance. Okay, so next is we get this length. Okay, so we get this length by using trigonometric functions. And first, since we are given with cosine of 2 theta, so we draw again a triangle. and this is 2 theta, the angle, and this is a right triangle, of course. So the hypotenuse is 3, so this is 3, and this, the adjacent side is 1. Okay, so the opposite side is just by Pythagorean theorem, the square root of 3 square minus 1 square. So opposite is equal to the square root of 9 minus 1. So opposite is equal to the square root of 8, or the opposite is equal to 2 square root of 2. Okay, so this becomes 2 square root of 2. Okay, so next is I want you to notice that this length is actually the opposite side of the angle 2 theta. And we are looking for this adjacent side. So we can use actually tangent because this opposite side is given to be half of the diameter, which is 12. So we just need to divide this 24 into 2. So this becomes 12. Okay, so tangent of theta, I mean 2 theta is equal to opposite of 2 theta, which is 12 over the unknown, the adjacent side of 2 theta. This length we do not know. So let's call this as A. So A, 12 over A. But tangent to theta is actually the opposite over the adjacent. So based on this, tangent of theta with this earlier triangle, the opposite is, if you go further, we have the opposite as 2 square root of 2 over the adjacent, which is 1. So that becomes 12 over A. So if you cross multiply to get A, so put A is equal to 12 divided by 2 square root of 2. So cross multiplying and putting A to the numerator on the left hand side of the equation. So this becomes 6 over square root of 2. A is equal to 6 over square root of 2. Then if we rationalize, square root of 2 over square root of 2. So this becomes 2. So this becomes 2. Then 6 divided by 2 is 3. So 3. So A is equal to 3 square root of 2. Okay, so now as you can see, I have highlighted this right triangle that we desire to get the representation of the sides with R. So one leg is R and the other leg is a combination of these two, R square root of 2 plus 3 square root of 2, and the hypotenuse is 12 minus R. And of course, by Pythagorean theorem, we can actually make an equation about that. So we have R square for the shorter leg plus uh, quantity of R square root of 2 plus 3 square root of 2. Okay. And we need to square this is equal to 12 minus R square. So, but we can actually write this R square, just copy that, and we can actually factor out this square root of 2 outside. So square root of 2 and quantity R plus 3. Okay. So we can write it like that. And we have here to square this, we have 144 minus 24R plus R square. And this should be square also. Okay, so we can simply copy just this plus this becomes square root of 2 square is this becomes 2 times R plus 3 square is equal to 144 minus 24r plus r squared. And we cancel this. So we simplify the binomial beside this. So 2 times r squared plus 6r plus 9 is equal to 144 minus 24r. So this becomes 2r squared plus, we just simply distribute. So we have 12r plus 18. Okay, so is equal to 144 minus 24r. So 2r squared. So this becomes positive. So if we put this negative 24 to the left hand side, we have plus 36r. And this becomes 18 minus 144 is equal to negative 126 is equal to 0. So if we divide this by 2 or multiply all by 1 half, so we have here r squared plus 18r minus 126 divided by 2 is 63. So 13 plus 50, so 63 is equal to 0. Okay, so next is we solve this resulting quadratic equation. So we can actually solve this by completing the square. So we have r squared plus 18, and we need to add something which is half of this 18, so that is 9, and square that. So if you square that, that is 81. And we simply put this negative 63 to the right hand side, so we have 63. And since we added 81 on the left, we add 81 here on the right hand side. So since this is a perfect square trinomial, so this becomes r plus 9 square, and this is actually 144. So but 144 can be written as 12 square. So 12 square. So 12 square. So if we get the square root of both sides, we actually get r plus 9 is equal to plus or minus 12. And we have actually to put this positive 9 to the right hand side. So we have r is equal to negative 9 plus or minus 12. And since we are only after a distance, so these two solutions we have negative 9 plus 2, negative 9 plus 12 is 3. And the other one is negative 9 plus, I mean negative 9 minus 12. This gives us negative 21. Negative 21. And since we are only after a uh, positive value because we need a distance, the right answer for the radius is 3. Okay, so for the final step, since we already know the value of the radius to be 3 units, so the area is simply equal to pi r square. If you are given the radius, so area is equal to pi times 3 square. So area will be 9 pi square units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution, and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.